Hey, so you are here to learn about quantum computing. Good, because it's genuinely one of the most interesting things happening in science right now. But before we can talk about quantum computing, we need to start somewhere smaller, much, much smaller. We need to talk about atoms. Everything you can see right now, your hands, the chair you're sitting on, the air you're breathing, all of it is made of atoms. Every single thing in the physical world is built from them. For a long time, scientists thought the atom was the smallest thing that could possibly exist, the absolute bottom, the tiniest building block of everything. Then they looked closer, and they found that atoms are actually made of even smaller things inside them, tiny particles called protons, neutrons, and electrons. Okay, so far so good. Small things inside small things. That makes sense. But here's where it gets weird. When scientists started studying these particles really carefully with proper experiments, they discovered something that nobody was expecting. These tiny particles do not follow the same rules as everything else. Think about your everyday life. If you put your bag on a chair, it's on the chair. It's not also on the floor at the same time. It's in one place. That's just how things work. But at the level of these tiny particles, that's not how things work at all. At that scale, what scientists call the quantum level, a particle can actually exist in more than one state at the same time. It doesn't have a fixed position until you actually look at it. And two particles can become so deeply connected that whatever happens to one of them instantly affects the other, even if they're on opposite sides of the planet. Not after a delay, not after a signal is sent, instantly. Now, I know what you're thinking. That sounds made up. It's not.
These aren't guesses or theories that scientists came up with over coffee. These are things that have been tested, measured, and confirmed over and over again in labs around the world for decades. This is how the smallest parts of our universe actually behave. The branch of science that studies all of this is called quantum mechanics, and it is one of the most accurate and well-tested areas of science that exists, even though what it describes sounds almost impossible. So why does any of this matter for computing? Well, and this is the part that's going to make more sense as we go through this course, some very clever people looked at these strange rules that govern tiny particles, and they asked a question. What if we could use those rules to build a completely new kind of computer? Not a faster version of what we already have, something fundamentally different, something that works by the rules of the quantum world instead of the everyday world. That's quantum computing. And that's exactly what this course is about. In the next video, we're going to look at the other half of the story, computers themselves, how they work, what they're built on, and why even the most powerful ones in the world still have limits.